What an interesting start to this summer. Normally by this time, many of us would be morphing into summer mode. K-12 districts wrapping up the school year, community and technical college instructors settling into their summer routines, university engineering programs putting winter semesters behind them. And for ATS Midwest, our summer instructor training would be in full swing. Our tech center would be buzzing with educators from all over the Midwest, learning the latest in Industry 4.0, robotics, automation, industrial controls, and CNC, sharpening their skills on cutting-edge technology, rotational learning models, flipped classrooms, and the like, all in preparation for fall. Well, all of that has moved to virtual, but that is another story. This summer is different, though, and the coming fall semester will be different, too. Will students be back on campus and in K-12 buildings? How many at one time? How will tech ed lab time be handled? What about PPE, keeping equipment sanitized and disinfected, keeping our students and our faculties and our administrators healthy and safe? We used to have 3 or 4 students using a piece of training equipment at the same time. Can we still do that? Perhaps the answer may be no. So lots of questions. But one thing I can tell you, as our team works with thousands of educational institutions and school districts, is that virtual skills and simulations will be a big part of education come this fall. There was a time when the question was, will a program use virtual and simulation tools at all? Were the instructor and the program chair open to using that technology in their programs? We don't have that conversation anymore. The new questions are, how much of the learning can be simulated? What are best practices in integrating virtual experiences into the curriculum? Which programs will emerge as the leaders using this technology? But at the same time, let's not pretend that virtual learning is the be-all and end-all. At some point, we must get students and learners back into the lab, learning on authentic technology. But the closer that we can get them to proficiency using virtual tools, the less likely that interruptions to and limits to lab time will inhibit our students' ability to learn. Or better put, students and programs that adequately integrate virtual and hands-on skills will end up ahead of those whose programs do not. So how should we look at virtual training? For the answer to this question, let's turn to the world of NASCAR. Now, there are certainly people on this call who are way more into auto racing than I am. Truthfully, usually by Memorial Day weekend, my eyes are glued to Major League Baseball, and being a cycling fan, I'm getting excited that the Tour de France is just about a month away. Not this summer, though. This Memorial Day was the first since 1880 that a Major League Baseball game wasn't on the calendar, and the Tour has been pushed back to late August. With NASCAR actually running races, albeit with nobody in the stands, at least sports fans have a sport we can watch. So it is that I found myself watching an interview of NASCAR driver Jimmie Johnson about a week ago. It turns out that in preparation for last week's race at South Carolina's legendary Darlington Raceway, since there were no qualifying runs, the practice for the race was virtual. The interviewer posed the following question to Johnson. He said, Darlington is known as a famously challenging track. How much can you prepare for it on a simulator? Johnson's answer actually tells us a lot about the effectiveness of virtual simulators. He says, the simulators are really great from a visual aspect. I would say it probably gets you 80 to 90% there. But that last little bit is what takes you from good to great. When it comes to industrial skills, to understanding AC/DC, fluid power, PLCs, and other controls, when we talk about automotive technology, CNC technology, robotics, servos, and so on, maybe the number isn't 80 to 90%. Maybe it's 70%, or maybe it's 50%. We could argue about that all day long. But let's instead agree on 2 things. First, virtual trainers will play a role in technical education going forward. They were proliferating before COVID, and the current crisis has just heightened our awareness of the value of these tools. And second, as Jimmie Johnson said, the last little bit, the hands-on experience, is indeed what takes a student from good to great. So today, let's talk about 10 simulators that get us to good so that our students are prepared as possible to get to great when they walk into the lab. These are just 10 of the dozens upon dozens of virtual simulation tools available. But when the ATS Lab Midwest team put our heads together and asked the question, which are the best, these are the ones that make the list. So let's get started. Number one on our list of the top 10 virtual trainers for industrial skills is the Electrical Systems Simulator by Amatrol. I love this simulator. We can look at schematics, we can look at diagrams, we can look at a wide variety of components, from circuit breakers and fuses, power supplies, resistors, switches, transformers, and wire testers. So let's try this. Let's put a DC power supply on the screen, and let's add a lamp and a switch. And then let's add our leads from the power supply to the switch, from the switch to the lamp, and from the lamp back to the power supply. Adjust our voltage, turn on our power, and hit the switch, and the lamp comes on. Simple enough, but let's try a couple other experiments. Turn off the power supply and remove that lead. What happens if a student connects the lead to the wrong terminal and turns the power on and hits the switch? Oh, we blew a circuit breaker, and now they can understand exactly what it was that created the problem. Let's try something a little bit different. We'll remove that lead. And now let's reconnect our circuit. And what student isn't going to crank the voltage all the way up to see what happens? Hit the push button switch and the lamp breaks. We can easily see exactly what took place. Student learns their lesson. They replace the bulb. So what happens if we do exactly the same thing, but we add a resistor? 25 ohm resistor, add our leads. Voltage is still all the way up. We turn on our power supply. And sure enough, we don't break the lamp. That is what virtual learning looks like. We can even add onto this a virtual multimeter and measure the circuit. So here we are turning on our power, connecting our leads. Believe it or not, we can overload the multimeter, adjust it, and now we can see that it's reading 19.85 volts. That is the Electrical Systems Simulator by Amatrol, and it is number one on our list of top 10 virtual trainers for industrial skills. Let's move on to number two, Automation Studio. This is the most powerful simulation software for industrial programs on the market. It combines electrofluid power, electrical technology, and controls technology into one multi-technology circuit design and simulation platform. Instructors can even clone the equipment that sits in their labs today, not choose someone else's equipment, but provide a perfect digital simulation of what is in their labs now. We can enable our students to build a circuit, either one that we design for them or one that they design on their own. They can activate that circuit and see it come to life, actually see flow circulating through it. Instructors insert or create links to their own documents or directly to outside websites, videos, and information that can support or explain the system right from the software itself. And they can create voiceover audio files that could shepherd a student through a circuit, explaining it along the way, addressing our auditory learners, our visual learners, and our kinesthetic learners all at once. For those of you that joined us 2 weeks ago, we saw Tim Tewalt, who's the program director at Chippewa Valley Technical College, demonstrate how he is using this powerful software in his program. On to number three. Number three on our top 10 virtual trainers is the Hydraulic Systems Trainer from Amatrol. This works much like the electrical trainer we looked at just a moment ago, but with hydraulic components, and a wide variety of them too. Small and large bore cylinders, cylinders with loads and extended and retracted springs, a directional control valve, cross and T-fittings, gauges, manifolds, motors, and a wide variety of valve types. Here we see the user connect a directional control valve to a hydraulic cylinder. This is an open sandbox. Unlike many simulators that only let a student set up the circuit one way, on this one they can actually set it up wrong. As we all know, students often learn as much from doing something wrong and figuring out their mistake as they do from being coached through the perfect solution. That is the importance of an open sandbox. By the way, we chose to share the amateur hydraulic simulator, but this company offers a great pneumatics trainer as well. Number 4, Interactive Labs by Quanser. This one applies a little bit more to advanced control courses at a university level engineering program, maybe an advanced technical or community college program, and it is so cool that we had to include it on our list. Quanser's Interactive Labs runs on a desktop or on a smart device. For those of you that are familiar with Quanser's Cube Servo 2 or their Aero, this simulator emulates the performance of both of these products. You can literally fly around with your mouse and see the training unit in 3D space. The Cube Servo version is a great tool for enabling students to experiment with DC motor modeling, proportional position and derivative control, speed and lead control, stability analysis, steady state error, and with the inverted pendulum, we add moment of inertia, pendulum modeling, crane control, and balance control. As we move over to the Aero, we simulate qualitative PID control, gain scheduling, state feedback versus PID control of a helicopter, optimal control of a half quadcopter. If this one catches your fancy, tune into next Wednesday's webinar, where we will do a deep dive on Quanser's Interactive Labs with the very folks who created it. Now on to Amatrol's Electric Relay Control Virtual Trainer. This is one of my absolute favorites. I am a hands-on kinesthetic learner, very tactile. I could sit in a classroom and listen to a lecture and literally nothing would stick. Not every student is like that, but that's how I was. Sit through a lecture about control circuits? No way. But learn by doing, and or, not nor, NAND, memory, normally closed, normally open. If I could do it, then it would stick. This virtual trainer drives home relay logic and control circuits like no other. Push buttons, selector switches, solenoids, motors, cylinders, ladder diagrams, symbols, control logic relays, directional control valves. It's all there. Here we can see an AND circuit, so that individual has to press both of those buttons in order for that circuit to work. Let's turn it off and remove some of those leads. In fact, let's remove all of the leads. And here we will set up a lead that goes from L1 to a normally closed contact to a solenoid that controls the cylinder. And let's see what happens when we turn on our trainer and hit the push button. The cylinder retracts because it's a normally closed contact. We can do all of the same things that we could do on a physical electric relay control trainer using this virtual version from Amatrol. And that is a perfect segue and the perfect precursor to number 6. Once a learner has been taught the basics of control logic, ladder logic, PLC programming, automation, fabrication, conveyors, motors, and so on, this simulator ties it all together. Step-by-step instructions, graphics, pictures, schematics, and logic elements. It is a perfect opportunity for a student to perform everything they learned in a PLC or controls course. Essentially, the student begins with a built-in PLC program that runs a conveyor. From there, the simulator offers 8 successive scenes, an operator station, a conveyor, a tank, 2 punch presses, 2 motors. By the end of the content, the student is building their own PLC program to run the entire line. They add all of their own ladder logic elements and build their own program. I think of all the capstone projects that I see in technical community colleges and engineering programs. And this is in a way a virtual version of that capstone project. Moving along to number 7 on our list of top 10 virtual trainers for industrial skills. This is the LJ Create Hybrid Vehicle Simulator. It starts out easy enough. We grab our key fob and we unlock the vehicle. We start it and place it into drive. Now we depress our accelerator and the vehicle begins to move. Down here in the lower right-hand corner, we can look at the battery charge. We can also take a look at energy regenerated, the amount of energy we're regenerating. We can look at our fuel economy. We can review our CO2. So let's set that on energy regeneration and head over to the left side. We can look at our component view and see all of the components in the hybrid vehicle. What if we wanted to look at a cutaway? We would click right here, and that shows us the cutaway. I love this power flow simulation. So now we can see the power flow from the internal combustion engine to the battery and so on. What if I set this vehicle on a decline and have it go downhill? Now we're using less power, and we can see that the internal combustion engine shuts off, and we are now driving power to the battery as we head downhill. Looking over here again on the left, we can look at our planetary gears, fully interactive. We can click on our fuel tank and see that. We can look at the battery. And perhaps the most unique thing is the way that we can teach troubleshooting. So we click over here on this next box, and it takes us over to a complete troubleshooting schematic. And now on the left-hand side, we can select a fault. The student doesn't know what that fault is. We select a fault, and then when the vehicle stops working properly, they have to figure out which component is the reason for the failure. So that is the LJ Create Hybrid Vehicle Center Simulator, number 7 on our list. We'll decelerate and depress our brake. Put the vehicle in park so that we can move on to our next, which is number 8. And number 8 is NC Guide by FANUC. Let's turn our discussion to CNC. One of our favorites here is the FANUC NC Guide. As we all know, FANUC owns the lion's share of the CNC control market in the United States. Essentially, this is FANUC's CNC software running on a personal computer. It's a great tool for demonstration of CNC programming and operation. If an instructor is teaching a distance CNC course, we can use this for demonstrating CNC. This is authentic FANUC CNC software. It's the real thing. If students are operating it from a device with a touchscreen, they can even press real buttons. It can run on a school PC, or a student can use it at home. NC Guide supports both milling and turning in both the most popular and the most advanced FANUC CNC controls. We can use it using a QWERTY keyboard or an OMG MDI. It even enables the students to load programs from an external source, update tool and workpiece offsets and setups, and update tool wear offsets as well. We have several technical and community college programs already using NC Guide in their CNC programs, and the feedback has been outstanding. It's a great tool to help a student hit the lab both confident and proficient. And from there, we move on to number 9, which is Amatrol's CNC simulation. When it comes to applied CNC simulators, this one from Amatrol is one of my favorites. The skills are spelled out on the written instructions, or the student can go off on their own. They learn to set it up apart, convert it from inches to millimeters. They can use code that's already loaded or program their own G code and M code. Once they are done programming, they hit the Start Program button and their program will run. As the part is machined, the applicable line of code is highlighted, so students of all levels can see exactly how the code is manifesting itself on the part, and vice versa. We can make changes to the code with the editor. If we program the tool to go out of the toolpath, the simulator will do exactly the same thing. It is the next best thing to being in the lab. And finally, number 10. Let's jump into FANUC's RoboGuide. Hundreds of educators all across the Midwest are already using RoboGuide to teach robotics technology to their students. We can use this software to teach all of the same competencies we teach on authentic FANUC robots: robot safety, programming, operation, jogging, frames, macros, and so on. Part of the beauty is the power of the software. From simple LR-mate programs we might see a high school student run to complex robotic work cells and everything in between. A student can take their program directly from RoboGuide to a physical robot and run the program, and we even have advanced programs tying this software to their data analytics curriculum. We see plenty of labs that integrate a teach pendant as well directly to the RoboGuide software for a unique hybrid between hands-on and simulation. So there you have it, our 10 favorite world-class virtual simulators. But that was just the tip of the iceberg. There are dozens upon dozens of these. In fact, the most common comment we hear on this topic is when people say, I had no idea that all of this was out there. But it is. And we have simulators for alternative energy and drone technology and motor control troubleshooting, measurement, mechanical drives and mechanical systems, energy consumption, industrial throughput optimization, production assembly, power tools, and the list goes on. As we look to fall, as we think about new ways to flip our classrooms, to optimize student health and safety, and to embrace a new way of learning, keep skills simulation at the forefront. We hope this overview is helpful. We hope it has sparked some enthusiasm for virtual training. And if so, for demo access or more information, please email info@LabMidwest. We thank you for sharing our mission to secure the American dream for the next generation of manufacturing talent.